Hello again, Steinhauer here. Welcome back. I'm going to start every class with a review question. Again, normally this would be on Top Hat, but for now, just pause the video and answer the question if you need to, and then come back. And sometimes I give the answer and sometimes I won't give the answer. So today's review question is, a light year is a unit of what? Time, distance, velocity, or energy? I am not going to give you the answer this time. So you can look it up if you don't know the answer. Great. So we're moving on now to chapter 3, orbits and gravity in the astronomy textbook. So this chapter delves with the history of astronomy. And the cool thing about the history of astronomy is that it's also the history of science. Science begins with astronomy. So what is science? Science is a discipline where we make models of the universe. We try to explain how and why the universe works through models, and then we test those models to see if they agree. And this is the important part. If they don't agree, we either throw the models out or revise them or come up with some different model. So the first application of this process was understanding the universe. It was understanding how the planets and the solar system worked. And it traces its origins back to the ancient Greeks. The ancient Greeks, people had for all of humanity's existence, searched for meaning, searched for reasons, searched for why things happened the way they did. Certainly people before the Greeks, civilizations knew about the motions of the planet. Certainly they knew about eclipses. There were civilizations who were very good at predicting timings of eclipses and knew exactly when and how these things would occur. But they didn't know the why. And almost always, up until the Greeks, the civilizations blamed or ascribed the cause of these motions to the supernatural. It must be gods, it must be deities, it must be things that we don't understand that are beyond our control. The Greeks were the first to, maybe we can understand this logically, maybe we can understand this geometrically, maybe we can understand this mathematically, maybe we can have a model that doesn't include deities. Now, it still had deities, but they tried to, as much as they could, make a model that didn't depend on the supernatural and the unknown. And that's the origins of modern science, trying to understand the origins of the solar system. And this is the model they came up with. You've got a system where the Earth is at the center of the universe. This is called the geocentric model of the universe. 400 BC or so, they were starting to come up with this. And all of the planets, again, this is important to know, all of the stars you don't need to really worry about because they're easy to explain. Of course, we know the Earth actually rotates once every 24 hours. But from our perspective, it looks like the sky, the stars, are rotating around us once every 24 hours. And we are the stationary ones. And that's literally what the Greeks thought were happening. They literally thought that the Earth was stationary at the center and that the stars were all affixed to some sphere or maybe holes in the sphere. And that giant sphere, which they called the celestial sphere, rotated around us once every 24 hours. This is a beautiful model of the universe. It works really well to explain the motions of the stars. It's wrong, and we would learn that later on, but it works, as a model, it works great. There are some problems with this model, though, when you get beyond the stars. There were certain objects in the sky that didn't just rotate with everything else around us once every 24 hours. Of course, the sun and the moon are like that. The sun and the moon do rotate around us with the sky, but within that model, the sun and the moon are moving. They are moving with respect to the background stars. And there are several other objects in the sky that move at regular patterns. And the Greeks called these things the wanderers, and we still use the Greek word for wanderers, planetos, today to understand the motion, to call these things. We call them planets. And these were things that didn't just follow along with the celestial sphere. The planets seem to move through the sky over the course of several months. And so the Greeks needed a new way to figure out how that worked. But that's okay. I mean, again, we're not completely devoiding ourselves of the supernatural. They still believe these things were gods, right? Mars and Venus and Jupiter are all gods. How else would they be able to move around the heavens the way they do? But they still wanted to describe them in a logical way. They wanted to describe their motions in a logical way. And so how are they going to do that? Well, that's okay. These are gods. They each have their own spheres. And that's really what you're seeing here, right? Mars has its own sphere, and Venus has its own sphere, and the moon has its own sphere, and the sun has its own sphere, and Jupiter and Saturn. I didn't point to those in the right order, but it doesn't really matter. Each planet has its own sphere and therefore can rotate at its own rate. Great. So this works fine, except that it doesn't really work. And I'll show you why. So these are the two guys you might have heard of that were foundational in coming up with this model, Plato and Aristotle. Of course, they had the geocentric model. The Earth was the center of the universe. Now, this may seem like an illogical point today, but back then it was perfectly logical. In fact, they used logic to reason why the Earth had to be at the center of the universe. There are several observations that you can make. They didn't understand inertia, for one thing, right? They assumed that if the Earth were they knew that the Earth was big, they knew it was a sphere, but if it were rotating, they figured that it would have to be moving really fast, which it is. And how then would this not cause, if you throw a rock up into the air, for that rock to go zooming off in the other direction? The Greeks assumed that objects would come to rest, and there was some standard of rest. We know that's not the case now, and we know that inertia is what keeps everything on the Earth, and there not be huge trade winds, and birds can fly through the air without being blown backwards. But the Greeks didn't understand that, and they assumed that if the Earth were really spinning like that, it would cause all kinds of crazy problems for us. So that's just one of the observations, but they logicked it out why the Earth had to be stationary and at the center of the universe. When I was learning about this, I figured, wow, the Greeks must be, how arrogant of them, how conceited of them to place themselves at the center of the universe. But it's actually quite the opposite. They considered the Earth to be lowly and base, and they considered the heavens to be perfect. And it was, so putting the Earth at the center was making it the worst. And in fact, this is where we get our concept of heaven above and hell below today. The closer you got to the middle, the worse it got. So on that same note, though, therefore, the heavens, which is where the gods live, must be perfect. And the Greeks were infatuated with circles and spheres and considered them the perfect shape. And so they ascribe not just the heavens to be these motions, but to have actual spheres associated with them, because the heavens were perfect and the sphere was a perfect object. And so these things all must be on spheres. So great, they have a model, but this model, again, doesn't really work all that well. It works great for the stars. It does not work great for the planets. Let's see if we can figure out why. Here is the basic idea. There is a phenomenon which all planets undergo, but which Mars experiences the most drastically, called the retrograde motion. And the idea is this. All of the objects in the sky, the sun, the moon, and all the planets generally move eastward through the sky. You can sort of see it here. Mars is traveling eastward and eastward and eastward. All of the sun and the moon do this as well, and all the other planets generally move eastward. However, all of the planets, the sun and the moon don't do this, but all the planets at some point during a multi-year cycle will stop moving eastward, slow down, move westward for a time, and then continue eastward again. You can see here we have, over a period of 10 weeks, the actual position of Mars as it changes. And you can see this retrograde motion, eastward, 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 slow down, move westward for a time, and then move back eastward again. This is easy to understand in the heliocentric model. Again, the heliocentric model is the one we know to be true today, where the sun is at the center and all of us planets are going around it. And in the heliocentric model, this is easy to understand, right? Mars and the Earth are both moving around the sun at fairly constant rates. And Mars isn't actually turning around and going backwards. It is just that it appears to move backwards as Earth passes, as we pass it in our orbit, right? We're in an inferior orbit, meaning we're closer to the sun, and we're moving faster in our orbit than Mars is. And kind of like when you're driving past another car on the highway and you see that car go by, it looks like as you pass it, that car is moving backwards, even with respect to background objects. You know it's not. You're both traveling in the same direction at constant velocity, but it looks like, compared to the background, as you pass this car, that it's moving backwards for time. This is what actually causes retrograde motion. And it's easy to understand in a heliocentric model. And all the planets do this at some point in their orbit, even the ones that are inferior to Earth. But this is very difficult for the Greeks to explain. And this would be a perfect opportunity to say, well, science doesn't work, our models don't work, I guess we'll just go back to believing in the supernatural. But that's not what they did. This is really where science begins. They made their models, they adjusted their models to try to explain the observations that they were seeing. And so they just made their models a little bit more complicated. If Mars being on a single sphere rotating at constant rate velocity cannot explain Mars, well, they weren't ready to use any other shapes, but maybe Mars deserves two spheres. Maybe if Mars is not just affixed to a sphere that rotates around the Earth, but is affixed to a sphere that is itself affixed to a bigger sphere and it rotates around the Earth and everything's rotating, then maybe the Greeks can explain what's going on here. And this is exactly what happened. So this guy became famous not because he came up with this idea, but because he made the most sophisticated model of the universe using this model that ever was made. And he was really the pinnacle of the Greek scientific method. Ptolemy wrote a work called the Almagest, which is called the Greatest Compilation. And it really was a compilation of all known science at the time. It was the cutting edge of every single science that had been developed up to that point. So it was a stunning achievement. And included in it was the most accurate and the most sophisticated model of the universe that had ever been developed to that point. And this is what it looked like. I don't know if you've ever played with those spirograph machines, but it looks a lot like a spirograph machine, and it works a lot like a spirograph machine. So again, Ptolemy's and the geocentric model of the universe needs perfect spheres. And the only way to get retrograde motion with perfect spheres is spheres on spheres and a phenomenon that we call epicycles. So this is basically how it works. You have a planet, and that planet is not on its own sphere, not on a single sphere, but on two spheres. Sort of like, imagine if you had a bicycle wheel and you attached a Frisbee to the rim of that bicycle wheel. And now both the bicycle wheel can spin and the Frisbee can spin, and Mars is attached to the edge of that Frisbee. Well, the Frisbee and the bicycle wheel are both invisible, but we can see Mars. So what's Mars's path going to look like from the Earth if we're in the center of the wheel? Well, as this Frisbee spins, we can make it so that every now and then Mars goes backwards. Mars appears to move backwards, even though both of these spheres are spinning at constant velocities. Mars itself will take one of these loop-de-loop patterns. And if you have the relative sizes of these spheres and the relative velocities at which they spin right, you can make a pattern that looks a lot like the pattern that the Mars actually takes through the sky. So that is the beginnings not only of astronomy, but the beginnings of science. Here is a model of the universe. Again, we know it's wrong today, but that's not even really the point. The point is they used a system of observations and tests to make their models better as they went along. And that's really the point here. Okay, we'll come back and figure out in the next video how we realized that this model wasn't right and the steps that went along to make the next model work. Okay, thanks. Sign her out.